Today we will talk about the third foundation of education, system. We have mentioned the three foundations. First is philosophy of education. Second, educational psychology. And third, systems in education. What we will talk about today will give emphasis to the concept of systems, followed by systems approach, which comprise system components, system development models, which what you have known and already understood was EDDI, but we'll introduce another one, ASMES. And finally, we will talk about system report. After you develop a system, you have to put into writing, put into the report. This videotape may be stopped into 2 or 3 parts in order not to let you watch too long. And meanwhile, you may be asked to discuss something with your friends, your peer friends online. Okay. Now let's start with this one first. Bus group. I think it might be a good idea for you to pair the group among 2 or 3 friends of your own. Now in this group we have maybe about 20, more or less. If you pick up 2 or 3 to be online bus group for discussing among yourself, it will be really good. So what I think you should be doing for about 10 or 15 minutes is to discuss among your friends on the 3 questions. First, what is a system? Second, what is a system approach? Third, what is the logical steps for designing or developing a system? Okay, we give you about 10 to 15 minutes. We will stop this videotape and then we will continue later on. Okay, start to answer the question, what is a system from your experience? Second, what is a systems approach? Third, what is the logical step for designing a system? Okay, I will stop this video. Okay, now you have your answer. Now listen to what I have to tell you about the system concepts. Okay. What is a system? A system may be defined into different definitions, depends on the people who express their ideas. First, system is a set of detailed methods, procedures, and routines created to carry out a specific activity, perform a duty, or solve a problem. Okay, this is a definition from businessdictionary.com. Okay. Or second one, system is an organized, purposeful structure that consists of interrelated and interdependent elements, which in this course we will call components, entities, factors, members, parts, so on and so forth. So it's an organized, purposeful structure. These components or these elements continually influence one another directly or indirectly to maintain their activities and the existence of the system in order to achieve the goal of the system. Okay. Third, all systems have 3 or 4 characteristics. First, the system must contain inputs, outputs, and feedback mechanisms. Second, the system must maintain an internal steady state called homeostasis, despite a changing external environment. Third, the system displays properties that are different than the whole. We call these emergent properties, but are not possessed by any of the individual elements. And fourth, the systems have boundaries that are usually defined by the system observer. So this is what you call, you may have heard open system or closed system. Okay. Okay, these will be the system concept. Now, okay, this is the conclusion that you may have to write the definition of your own system. This is mine. This is Professor Chayong Bramong's definition of the system. The system is an organized, purposeful, structured, and integrated identity comprising interrelated and interdependent components and elements working closely and continually, directly or indirectly influence one another to achieve a common goal and objective to achieve common goals and objectives through a well-designed logical steps under specific context and surrounding circumstances in which the system works to maintain their activities and the existence of the system. Okay, these are the definition of this system in conclusion to 1, 2, 3, or what you have studied. Okay. Now the second point we'll discuss is the so-called system components, which you may have heard of system elements or system parts, but this one we'll call each part that combine to be system components. Okay. What is a system components or SC? System components refer to anything at all called components, elements, composition needed to be integrated into a system comprising input component IC, process component PC, output components OC, and feedback components FC, all of which are related under the same context or settings SC to facilitate successful working environment to achieve the set goals or objectives. Now on this screen, give attention to IC, input component, PC, process component, OC, output component, and FC, feedback component. But all of these will be under the so-called setting or context. Okay. When you design the system, you have to identify the components, which we will talk about later on. You have to start from what? You have to start actually from analyzing the context from here, SC. Because if you develop a system without considering the context or setting, will bring a lot of problems. For example, people go to study in the United States or Europe or England, whatever, just like myself. I got PhD from California. When you come to develop the system without analyzing the context of Thailand, chance might be that you will develop or replicate the system from America to work in Thailand, to be implemented in Thailand, and it doesn't work. This is what happened to Thailand, because we tend to follow the Western concept of everything. Democracy, we follow the British. Education, cultural, you see, this kind of jacket or necktie are not Thai. This Western, which you call it universal. I wonder what is universal. How about Chinese? They have their own dress. Thailand, they have so beautiful dress. This should be also universal, not just anything that you have to put the tie on in the very warm weather like Thailand or southern part of China. See? So what I'm thinking is that before starting the system, you have to look at the SC or CC context setting components. Okay, and then you have to start thinking about the IC components, followed by PC components, OC and FC. You put in 1, 2, 3, 4, 5 steps. Okay. So another point is that any change of the components in the system, the change in input, in process, output, or feedback, of course, it affects other parts of the system. Any change of any components inevitably affect other parts of the system. Okay. Of course, this is the so-called modification. But in modifying anything, in modifying the components, you have to keep in mind that when you change number 1, it affects number 2, number 3, and number 4. Okay. This is the so-called GS model, or a general system model. When we think in our head about a system or classical model of system, first you see the context surrounding the whole thing. See the context or the setting, and then you see there will be input, process, output, feedback. So the whole thing, when we look at the initial part of the word, it becomes CIPOF SIPOF, CIPOF SIPOF model, which we'll talk about later on. Okay. But just remember this. This is the GS or General System Model. Okay. In terms of system components, there are 2 concepts. When we work out the system, first, structural concept. Second, process concept. Okay. Structural concept, what does it mean? by the concept based on structure of the components or by the structural concept. System components are physical, non or not easily changeable, such as what? Infrastructure, equipment, materials. They're not just dissolve or vaporize away. They will be with us for a long time. Okay. How about process concept? System component in terms of process concept. The system components are adjusted and changed accordingly to the structural components and by space and times. Process meaning do what you have. For example, if you want to do the som tam in Thailand, you know, som tam is a papaya salad with lamb and chili, not just only salad without any spicy things. If you don't have papaya, you may make use of other things, such as in the US, because we've modified the papaya in some part of the states. We use carrot, for example. So in this case, when you use the carrot instead of papaya, you have to adjust and change the methods according to the structural components. You replace A by B components for something like that. For the process, it's based on the method, the way they approach the step you have to do. Okay. So there are two types of system component also, in other words. First, abstract, unperceivable by hand, ears, or eyes. Okay, abstract. Importantly, ideology, the ideal situation, comprising philosophy. What is philosophy? Do you have your own philosophy? Philosophy is the statement of your faith and value that you want to set as guidelines for yourself to conduct your life. In case of corporate philosophy, is the statement of guidelines of faith or values that you want to conduct your organization. After you set the philosophy, you have to set the mission. Mission is the main task that you want to accomplish. So it's mission possible, not mission impossible. Mission, usually you have to state it in a very easy form. Later on, I will explain to you the 4 characteristics of writing mission statements. But now, let's skip to other. And the third is vision. What does it mean by vision? Vision is the statement of the images of success. When you have vision, that means you see the picture of success in your mind. And you have to write it down. So there will be more than one vision, of course, 2 or 3 or 4. Okay. And then finally, commitment. What you will commit yourself to do to achieve your mission, to achieve your philosophy, and to full up, to make it full according to your idea or ideology. Okay? So abstract means ideology, intangible components that cannot be seen or heard or touched by your five physical senses. Now, the second type of system component are concrete components. Mostly are physical, touchable. You can bring it up. See, you can hear, you can see, and other tangible components. Okay. Now, we will stop here before we move to the second part of our video clip, system behavior.